Hello students, let us today talk about gravitational potential energy. Okay, I will first discuss the formula part of it, then we will see why it is like that. So here main thing is the problem with the sign conventions. Okay, so let us say this is Earth. Okay, there is a point here A and there is a point here B. So this distance is RA. We are measuring from the center of the earth. It is small rb, small letter rb. Gravitational potential energy is denoted by a symbol U. Alright. So UB minus UA. Okay. The difference of potential energy, obviously at this point it will have some potential energy. It will have some potential energy. The difference of potential energy is given by minus of Gm into small m divided by 1 upon Rb minus 1 upon Ra. So first thing, you know the formula. Okay, there is a minus sign, there is a minus here. Ub minus Ua is equal to minus Gmm 1 upon Rb minus 1 upon Ra. Now in the same thing, now this point B, let us say it is very far off. It's very far off from the earth center. It is almost at some infinite distance. So can you write here U infinity minus UA is equal to minus Gmm divided by 1 by very large number, this becomes 0 minus 1 upon Ra. So UA is equal to minus plus, again there is a minus, so Gmm by Ra. So if you want to find the potential energy at a point, so at A, the formula is minus Gmm, m is the mass of the earth, small m is the mass of the object, divided by the distance from the center to that point. Okay, so we will see how it has come. Okay, remember that when you are calculating this potential energy, you have in the denominator, do you have Ra square or Ra? So you should note that difference. You have Ra, right? You have only distance. See, before we get into this potential energy business, let us understand few small concepts. Suppose this is a wall and this is your floor. Okay, this is your another wall. You have a small object, a small block. Okay, you have to take this block from this point to this point. Okay, one way is simply put it over here. We will not talk about that. We will push this block to this location. Okay, we will again push it to this location, then again to this, slowly, like that we will slowly bring it to here. Okay, so what we have done here, there is a block A which we have shifted from this position to this position by giving small incremental work we have done, and we have taken it here. So let us say this small work is W1, this is W2, W3, so on and so forth. If I want to find out the total work, can I write it is the sum total of all these individual works, then I get the total work, isn't it? So work basically is force into distance. Work is force multiplied by distance. Vector wise you want to talk, it's a dot product of force vector and the displacement vector. So basically what are you trying to do? You are pushing this object from this point slowly to this point. So can we write in integral form each, let us say this small amount of work, all this W1, W2, W3, all these are small amount of works. So let us say that small amount of work is dW. So what is that small amount of work? Some force I have taken and I am displacing the object by some small distance dr, or you can say ds, whichever you feel comfortable. Ds is a small amount of displacement given to that block. Okay, so this is one work. I want to get the total work. How will I get? So I need to integrate. Okay, so when I integrate, I get the total work. I get W will be integration of dW. Okay, so this is the concept involved in when we are using calculus. So when we talk about small incremental works and all that, so this is how we calculate the work. So now look here, this is your ground. Okay, this is let us say this is an apartment. Okay, this is first floor, second floor, third floor, like that. So you have a ball or a block. So let us say this height is h, this height is 2h, so on and so forth, 3h, 4h and all those things. Now this block which is at this position right now, it has been shifted to this position q. Okay, the block from here to here, it has been shifted. So some work must be done here, some work has been done. One way is some magic must happen and this block should go from here to here. Okay, but that is not the case. The second case is some human has done some work to pick this ball or the block from here and kept it over here. That means some work has been done. Okay, now what that work happened on the body, where did it go? It got stored in the body as a potential energy. The work done here. Now this work, is it internal work or an external work? Some person must have done the work. You might have brought some crane and picked this block from here to here, you have put it. So if you have put it means you have done some work. So that work done has been stored as a potential energy in the block. Okay. So can I say in this way that at this level there is some potential energy. At this level there is some potential energy. Okay. What that potential energy, let us not discuss about that right now. Okay. So there must be some potential energy difference. We are calling this as UQ and UP. Okay. So if you take the potential energy at this level and the potential energy at this level, the difference will give you work. Positive work, negative work, sign convention, that we will see. So this is one thing you need to understand. So this is your ground. So this is your earth. This is your earth, and just imagine, you are moving above the earth. Okay. So this is somewhere is earth center, right? So if you are moving and going on and so forth till infinity means you are getting into space. You are getting into space. So first thing you need to understand is, so difference of potential energy will give you work. See students, these concepts what you are seeing in this gravitation chapter, they are very important from the aspect that in your class 12, again you are going to study about electricity, electric field and all these things. So those things will be comparable and similar to the concepts what you are seeing here. So you have to understand the concept behind all these things. Okay. Now we will talk about gravitational field. So without me telling also, you must have got some idea about it. So let us say this is your earth. Okay. Now first of all, gravitational field is an imaginary concept. Okay. It has been made to make our life easy to understand few things. Okay. It is an imaginary thing, you cannot see, but you can feel it. It's like that air, you cannot see that air, but you can feel it. So this is your earth. So you picked an object from earth, means this is the radius of the earth, and I am talking about some particular location. So let us say this is RA, this is point A. You are going above and above and above. Okay, what will happen if you take at a particular point, you just release it, it will fall back towards the earth. Why it will fall back? Because it is falling back because of the gravitational force between the that mass and the earth mass. Which mass is huge here? The earth mass is quite huge when compared with that small mass. Obviously, it is falling towards the, suppose you have some another small mass over here whose mass is negligible compared with the earth's mass, which there will be some gravitational force in this direction also, but which is massive. This is massive, right? So without doing anything, if simply if this chalk is there, I simply leave it, it will fall to the ground. Don't have to do anything for that. So similarly, you are pushing this object slowly, in the vertically upward direction, far away from the earth. What will happen? See, just imagine some circles over here. Okay, like this. Imagine. So here what happens? When you are pushing this object, let us say from A to B you have taken, there also you released, it fall down. From C you went, there also you release it, fall down. You so on and so forth, you are going and you reach a point where you ended up in space actually. You just left that object and it is there only, it is not falling back. So what is happening? So around this earth there is some field. So in that field, when you are keeping the object, it is getting attracted towards the earth. Okay, attracted towards the earth means because of the gravitational pull of the earth. So there is an imaginary field around the earth where this gravitational force is active. So if you are moving beyond that field, so called imaginary field, you are ending up in kind of space, in kind of vacuum, where this force is no longer active and the object is getting a weightlessness kind of a feeling. Okay, so try to feel what is gravitational field. Gravitational field, every object has a gravitational field. It's not just earth. You take any object, okay, so it will have its own gravitational field around it, okay, up to a certain distance. But because we are talking about earth here, we are talking about a gravitational field. Now pay attention to this. Let us say this is your ground now. There is a block here and it has been raised to another location from A to B. It has been, the block is now right now here, and now after some time it is here, it has been put over here. Some work must be done. That's what we have discussed now. Now at this point, let us say it is still in the gravitational field. Do you have to do anything? Suppose you simply release it, it will fall towards the earth. Again, this is your earth. I have drawn only this line, means it is a surface, it will fall towards the earth. So if it is falling towards the earth means the earth's gravitational field is doing some work. Okay, let us call that work done by the gravitational field or work done by gravity or whatever you call it. That is why it is WG, suffix G, just for our identification purpose. Okay, now this object which was here and which arrived here, that means some external work is done, either by the crane or the person or anything. Some external work has been done so that this object has gone from here to here, right? Now tell me, this work, which the external work that has been done, is it in the direction of gravitational field or against it? See, gravitational field is acting in this direction, gravity is acting in this direction, and you are doing some work in this direction. So because of that, this object from here to here it reached. So let us say the work done by you or an external agency is W suffix ext, W external. Let us talk only the direction part now. So if the work done by the gravity, because this object will be falling from here to here without doing anything, okay, so if that you consider as positive, this is against it. So can I say they are mutually opposite? Whether the magnitude is same or not, that we will see. But what about the direction? They are mutually opposite. That means a work done externally on an object to pick that object from one point to another point. Here we are talking in the vertical direction only. Okay. So it must be against the gravity. Now see here, suppose this is your surface of earth and there is some block at location A. Location B is your surface and it is freely falling. So if it is freely falling, the acceleration will be equal to acceleration due to gravity, right? We are discussing only the magnitude part here. So obviously, what is the meaning of this? Suppose if I take intermediate points 1, 2, 3 and then B. So first point is A, 1, 2, 3, B. So the velocity here, and velocity here, is it same? The velocity is changing actually because the block is accelerating towards the earth. Okay. So this point first you have to understand. Now let us talk another point, because I am going to use all these concepts in the further discussion. That's why I am telling all these things. You see here, we have done this energy conservation problems here. There is some block here and there is some block here. Okay. So here there is initially the block is at rest. So it will have what? It will have potential energy, right? So it is rolling down the hill. So at this position, what was the concept we have applied? We have applied total energy at P is equal to total energy at Q, isn't it? So what happened here? This potential energy converted into the kinetic energy of this block, and there is some potential energy also here. Okay. If you consider the block here, there is only kinetic energy here. There is no potential energy here. It is mgh now. So here at ground the height is 0. So this whole potential energy got converted into kinetic energy. Simple. Now that means from here to here this block came, means some work is done, isn't it? Now tell me, let us say I slowly push this block to here, some position 1. Okay, very slowly, very slowly, dead slowly. Then I again push it. Then I again push it. After very dead slowly I am going to do this. I will do this in 1 hour time, then I will do this another 1 hour time, and slowly doing all this, I reach it here. In this case, is this work done? Any work done? There is work done here. Now tell me here, is this block accelerating? Is this block accelerating? It is not accelerating because you are doing small increments of work. So you will find this term small increments of work. So you have to understand this very carefully. Small increments of work means what? You are not accelerating the block. You are not accelerating the block means the velocity was constant. But slowly you are pushing the block down the hill. Now if I go in the reverse way, see if it was like this. So if I am going this way, is it valid then? Even then it is valid. Even this block will come over here, then it will come over here, then it will come over here, and finally it will go over here. Now is this block under any kind of acceleration? The block is not under any kind of acceleration. So can I call this as external work here? External work. I am doing this external work to pick this block from this point to this point. Now imagine this as a vertical. So I am doing some external work from this point to this point, isn't it? Okay? And I am slowly pushing this block from here to here. While doing this, I am working against the gravity. But the block is not experiencing any acceleration as explained here. Alright. Now see this. This is the ground surface, okay? Now I give you one position, this another position, okay? This is position A and position B. Where at ground the potential energy is 0. No big points for guessing this. mgh, h is equal to 0, so potential energy is equal to 0. So where do you think the potential energy is more? PB and PA is there. PB is more than PA. So if I take position C, here the potential energy is more than this. Here it is more than this. Here it is more than this. Okay? So the potential energy actually is highest here, second highest, third highest, least. Okay? So understand this point. So we will see now expression. Okay. Now let us come to the mudde ki baat. the whole thing where we have started is, this is our Earth. There is a location here A, there is a location here B. Okay. Now this distance is RA, and this distance is small rb. Now usually this distance RA and RB, they are represented from the center of the Earth. It's a standard notation. You should write small only. You should not write capital. Capital means usually is represented for the radius of the Earth. Okay. Now the object from here to here, we have just seen that if you have pushed this object from here to here, you have done work against the gravity. Then only this object must have gone from here to here. And during this process, there is no acceleration happening because I use the term small increments of work. Okay, we are going like this, let us say. And so the difference of this potential energy must be some work done, which is the external work done. Then only it is possible. If you give energy, if you give work, if you start doing small work, this will go from here to here. Now that much is clear now. Now what is this work done externally? You know that this work done externally is basically it is against the gravity, right? So how is work defined? Force multiplied by distance. What force is involved here? Force due to gravity is involved here. Okay. So we will write it now. Okay. So what is this force due to gravity? F is equal to G M by, if you are talking about here, just a minute, just fallen down. See how this object came here. Let us say it was originally here, from here to here it came, then from here to here it went. Okay, by doing some external work only. No? So at what is the amount of work done to bring it over here to A location, and let us say to B location. So it will be the force due to gravity, G m1 m2 by r square. Here distance from the center is given as rb, right? Rb square. This is the force, okay, multiplied by the distance from here to here. What is the distance? It is rb. So if you put it over here, it just becomes G by rb. Now if you remember, now this, in the force due to gravity, there was a minus symbol here, and I told you also why it is minus. Okay, so there is a minus here. Okay. So what is the work done now? This much amount of work. So if you expand this, you get minus G by rb. So this much amount of work must be done if the object is here. Okay, minus in a similar fashion we can argue, and we can write for this location also. So basically what we are trying to do is we are finding the difference in potential energy. Okay, that potential energy is basically work done. Okay, and what is the work done? Work done is horizontal distance. So which force? Gravitational force. So like that we have, if the object is here means it must be having some potential energy. That potential energy in the form of work we have calculated. Okay, so this minus of minus becomes plus. So this is G by rb plus G by ra. If you take minus common and G common, it is 1 upon rb minus 1 upon ra. So the difference in potential energies between location B and location A is given by this expression. This is where we have started our original discussion. So this is the proof for it. Okay. See, the whole way this argument is presented is like, difference in work done is stored as potential energy. Okay, or difference of potential energy is actually the work done by the object. Okay, that is how we have the whole thing we have presented, and the expression was ub minus ua is equal to minus gmm multiplied by 1 upon rb minus 1 upon r. This is what it is. Now this is your earth, this is your location A, and very far off, let us say at infinity is there. I am calling that location B right now. So if you put at infinity, so it will be u infinity minus ua is equal to, this term will become 0. So it is becoming gmm by ra, or u infinity is what? U infinity at a very long distance, what is the, see 1 upon infinity you are putting. So 1 upon infinity means 1 upon very large number. So this term is becoming 0. So this is becoming 0. So essentially this is 0. So UA is gmm by RA. Okay. So potential energy at A is minus of gm. M is the mass of the earth. Small m is the mass, capital M is the mass of the earth, small m is the mass of the body, and RA is the location from the center of the earth. So can I write the general expression U of R is equal to, U of R means at some particular location R, it is gmm by R. This is what you have to understand. See, one more way of understanding this is some infinity, means somewhere in space. So suppose a particular object is right now at location A. So we are understanding it in this way that originally it was at some infinite distance. From there, let us say it was here. So slowly, small cheaty type of work we have done, and after billions of years we have got it here now. Okay. So the potential energy expression to calculate is U of R is minus, do not forget to put this minus, and why the minus has come I have tried to present in a simpler way. Okay, so let's move on. So when we do some numericals you will understand what I am doing actually. So this is the whole energy behind the potential energy or gravitational potential energy, because gravity is involved in whole this thing. Okay, gravity is involved in all this thing. So when you in electrostatics, when you talk in class 12, similar concept I will be discussing there also. So because there electric field we are involving there, we will call electrical potential energy. Okay, electric potential energy. So this is the expression, make a note of it. So just to understand, suppose you want to find out at a point A, which is, let us say, at a distance of 7,000 kilometers from the center of the earth. What is the gravitational potential energy you want to calculate? See, radius is 6,400, right? So balance is this 600 kilometers. Okay. So U of A will be minus gmm by RA. Okay. So G value 6.67 into 10 to the power of minus 11. Mass of earth 6 into 10 to the power of 24. Let us say the mass of the object is 10 kilos, 10 kg, okay, 10 kilos divided by RA, it is 7,000 kilometers. So into 10 to the power of meters. Whatever you get, so many joules. So energy is measured in joules. Okay. So this is how it is. Okay. So this is what we have learned today, how to calculate the gravitational potential energy at a point from in the gravitation field. If you go beyond the gravitation field, no question of any gravitational potential energy.